Hi, welcome back to another Dive in 5 today. Today we're going to talk about numerical patterns for 4th grade and focusing in on those prime and composite numbers. I'm Bailey Murphy, Math DRT. Before we get started, I want you to complete this first task. When the task comes up, you're going to pause the video, complete the task on your own or with a team or partner. And while you're completing the task, think about what does student learning need to look like for students to be successful with all components of this task. Here you are. Go ahead and pause the video. We'll see you back. Welcome back. Let's talk about the progression with best for this benchmark. In 3rd grade, students were expected to explain and determine if a number between 1 and 1,000 is even or odd. They had to multiply two whole numbers from 0 to 12 and divide using those related facts, as well as determine if a whole number between 1 and 144 is a multiple of a single digit number. In 4th grade, students are going to recall multiplication fact with factors up to 12, as well as those related division facts with automaticity. They're going to determine factor pairs for whole numbers from 0 to 144. They're also going to determine if those numbers are prime, composite, or neither. This learning will continue on in 6th grade when students will be expected to find prime factorizations of specific numbers. In this video, we're going to focus on these bolded statements where we're going to focus on finding factor pairs as well as determining if a number is prime, composite, or neither. In 4th grade, students are going to build on that understanding of using arrays to multiply two whole numbers between 0 and 12 to find the factor pairs of numbers between 0 and 144. Students will also use these arrays to determine if numbers are prime, composite, or neither. Instruction first needs to start with those concrete models and students actually building the arrays so that they can understand how they can manipulate and move it into different rows and different arrangements. Students can then move to drawing representations of arrays and using those T-charts to help record factor pairs. As students are working with factor pairs, they can have discussions about the divisibility rules and how these rules could be used to determine the factor pairs of a given number. As we begin our work with factor pairs, we want our students to use those concrete manipulatives to be able to create all possible arrangements and arrays for a given number between 0 and 144. Each array provides a factor pair, which are two factors that when multiplied together equal a given number. On the screen I have the number 12 and I've arranged it into several different arrays. I have one row of 12, two rows of 6, and three rows of 4. Each of those individual numbers is a factor of 12, and when I put them together, so 3 and 4, that is a factor pair because 3 times 4 equals 12. When we're giving our students numbers to build concrete models of arrays, we want to be really purposeful about the numbers that we use to be able to give a discussion about prime, composite, or neither. If we think about a misconception that our students often have with prime and composite, they usually believe that all odd numbers are prime. However, if we are purposeful in selecting our numbers and ask students to build an array for the number 9 and the number 7, they can begin to see that the number 9 has several different ways we can arrange it. We can arrange it to be one row of 9. We can also arrange it to be 3 rows of 3. However, the number 7 only has one way that it can be arranged, and that would be one row of 7. Meaning the number 9 is composite because it has more than one set of factor pairs, and the number 7 is prime because it only has one set. It's important to note that the number 1 is actually neither. It is not prime and it is not composite. As students work with building models of arrays, we also want them to draw representations as well as record those equations. You can use graph paper, you can use dots to make your arrays. Notice that all of these arrays are labeled with an equation showing how many rows I have and how many are in each row. So for the number 16, I have one row of 16, two rows of 8, and 4 rows of 4. Using a T-chart is going to be a great way to help students stay organized and ensure that they found all possible factor pairs. So take a minute and look at this T-chart and think about what do you notice about the numbers that are listed. Hopefully you notice that the numbers start to repeat themselves. Once the numbers start to repeat themselves, we know that we have found all possible factors. Going back to this task that you had at the beginning of the video and thinking about what students' learning needs to look like in order for students to be successful with this task, we know that students are going to have to be able to identify factors and factor pairs, and as well as identifying is it a composite or prime number. As students are exploring factor pairs, they may begin to recognize divisibility rules and can use these to determine factors of a number. Some divisibility rules are all numbers are divisible by 1, all even numbers are divisible by 2. A number is divisible by 5 if the number in the ones place is a 0 or a 5. We want to make sure that we plan really purposeful questioning to help students see these patterns when they're finding factor pairs. So for example, students could find factor pairs of a set of numbers, and a question we might ask is, what's a factor all of your numbers have in common? We know that all numbers have a factor of 1. As we think about the CRA model with finding factor pairs and determining if numbers are prime or composite, we know we need students to build those concrete models so that they can physically manipulate the tools and figure out all the possible arrangements. Students can also move to drawing on graph paper or using dots to create those arrays, as well as labeling them with equations. They can move to that abstract thinking using the T-chart, as well as some of the divisibility rules. So the number 24 is even, which is divisible by 2, so we know that 2 is a factor of 24. It's important to note that the goal is not to get all students to abstract thinking. The goal is to build really strong bridges between the concrete representation and abstract thinking so students can go in and out at any time. You may find that students are really successful with representation and abstract thinking when they use smaller numbers. However, they may need to dive back into that concrete thinking when they get some larger numbers to see how those are related. Thanks so much for joining me today to talk about prime and composite numbers for 4th grade. I hope to see you again for our next Dive in 5.